Assalamualaikum dear viewers, Shoaib and Dayo is here with a new lecture of electrical engineering, and today's topic of our lecture is the coefficient of coupling in the magnetic circuits. So the coefficient of coupling can be easily defined as it is a fraction of the magnetic flux produced by current in a one coil that links to an other coil. So as you can see the diagram, there are the two coils, the coil A and the coil B. Always in the mutual induction process we need the two coils, okay. So if the current is to be changes in a first coil, whenever coil A is supplied from the AC supply, then the current is to be varied and current is to be changed in a one coil that magnetically links or magnetically coupled to another coil. Then obviously in the coil B the EMF will be induced in the coil B. So that induced EMF will be which is to be produced in the coil B is due to the magnetically linkage or the magnetically coupling. Now, and if we recall the concept of the self-induction process, so what happened? Whenever a coil changing current, carrying current, a magnetic field is established. If a simple coil which carrying the amount of the electrical current, so a magnetic field is established, and if the current in a coil is changes, if the current in a coil changes itself by its own, then EMF is induced in that particular coil. So that will be called as the self-induction. Now let's discuss the coefficient of coupling, which is denoted as the K over here. When entire flux of the one coil links to another, the coefficient of coupling is the 1 or 100%. So the coefficient of coupling K value always, this K value always is in between the 0 and the 1, from the 0 and the 1. So if you can see, this coil A and the coil B both are magnetically coupled, okay, and when this when the value of the K, coefficient of coupling value is the K is equal to 1, so 100% maximum the flux linkage or magnetically coupling is to be done in between these two coils, okay. Now when entire half of the flux is set up in a one coil, so the coefficient of coupling value is the K 0.5. For example, if the K is the 0.5, only the 50% of the magnetically linkage or the flux is to be linked by the two coils. So this is the coefficient of coupling. When the value of the K is equal to the 1, so entire flux is to be linked within between these two coils or linked with another coil from the coil A to the coil B. And if the coefficient of coupling value is the K is equal to 0.5, then half of that magnetic flux is linked with another coil, so that will be the 50%, okay. Now if the two coils have the self inductances, obviously both these coils are magnetically coupled and mutually induced EMF is produced, okay, because if the coil A is supplied by the, which is carrying the current from the main supply, then what happen, if this current is in a supply in a coil A is changes, and obviously an induced EMF is produced in the coil B according to the magnetically linkage or magnetically coupling. So this is called the mutual induction process. So if the both coils have the inductances, for example, if the coil A has inductance its own, which is the L1, and the coil B of inductance its own, which is the L2, so what will be the expression for the mutual inductances between them is given by M is equal to the K L under root L1 and L2. So this is the our expression. So what this K shows? This K shows the coefficient of coupling that can be defined as the friction of the magnetic flux produced by the coil A that links with the coil B or links with an other coil. So where the K is the coefficient of coupling, clearly mutual inductance M between the two coils will be maximum whenever the value of the coefficient of coupling is equal to the 1. So maximum value of the magnetic flux is coupling in between the two coils is happened when the K is equal to the 1, okay. So if the flux in a one coil does not link all with the another coil, so the value of the K is equal to 0, means what happened, whenever the total flux is not linked with another coil and does not link with the other coil, so what happened, the K is equal to 0 and the coefficient of coupling will be equal to 0, okay. So under such conditions, the mutual inductances between the two coils will be equal to the 0. So again I am writing these conditions, k is equal to 0 and k is equal to 1. If the k is equal to the 1 means if the coefficient of coupling is equal to the 1 between these two coils, then what happened, in such conditions the mutual inductances, now in this condition whenever the k is equal to 1, the mutual inductance, okay, between the two coils is the maximum one, because both coils are tightly magnetically coupled. But whenever the coefficient of coupling means the flux does not link with another coil, then the value of the k is equal to 0, and in that condition the mutual inductance value will be equal to the 0. Why? Because from the simple expression m is equal to k under root L1 and L2. If the k is the 1, obviously maximum mutual inductance you can observe, and wherever, for example, if the value of k is equal to 0, so 0 multiplied by under root L1 and L2, so m will be equal to 0. So according to the mathematical expression, so whenever k is equal to 1, so coefficient of coupling or the mutually induced EMF between the two coils will be tightly coupled, and both coils are magnetically coupled, and whenever the coefficient of coupling value is equal to the 0, k is equal to 0, so according to the expression mutually induced EMF or mutual induction between the two coils will be equal to the 0. So consider these two coils, the two magnetically coupled coils A and the B having N1 and N2 turns are respectively. You can see these are the two coils, and N1 is the number of turns on the of the coil A, and N2 is the number of turns of the coil B. Suppose I1 current is flowing through the our coil A. Your coil A is supplied from the AC supply, and due to the supply I1 current is to be flowing from the coil A, and which is produce a mutually flux phi1 2. So this one is for the creation of the magnetic flux, and that magnetic flux linked with the coil B, and obviously mutually flux phi1 is that part of the flux created by the coil A that links with the coil B. So phi1 is the mutually flux is due to the induced by or created by the coil A, and that phi1 links with the coil B. Okay. Now induced EMF, okay, so m di1 over dt, so from first coil is that d by dt of the mi1, okay, and in the second coil n2 d phi1 over dt is equal to n2 phi1. So if you can write these expression mi1 n2 phi1, so from this we can easily calculate the expression of the mutual inductances in the mutual induction process. So m is equal to n2 phi1 over I1. From this expression we can easily calculate the mutually induced EMF. Okay, so n phi over I is the expression for the mutual induction. So this was the lecture regarding the coefficient of coupling in the mutual induction process. So the coefficient of coupling can be easily simply defined as the fraction of the magnetic flux produced by the current in a one coil that links with another coil. If the value of the k is equal to the 1, so the 100% magnetically coupled or tightly magnetically coupled coupling is to be happened between these two coils, and if the k is the 0.5, then 50% of that magnetically linkage in between these two coils, and if the value of the k is equal to 0 means all flux is not to be linked with another coil. So what happened according to the expression m is equal to that k under root L1 L2, if the k value is equal to 0 then mutually induction between these two coils is equal to the 0. So this was the lecture regarding the coefficient of coupling in the mutual induction, and I hope that you have understood today's lecture, and at the last please do subscribe my YouTube channel Shoaib Ahmed Dayo for more informative videos related to the electrical engineering area. Thank you.